Hi, I'm Paweł from Nordic, and today we'll explore the nRF54L series. Ultra-low power wireless SoCs supporting Bluetooth LE, Matter, Thread, ZigBee, and proprietary protocols. Since you're here, you're surely interested in these devices, and you may be considering this product for your next design. In this session, I'll help you find out a couple of things. Does it have the features you need? Does it have the performance you need in terms of power consumption, wireless connections, and processing? We'll look at specs. We'll also have a look at supported applications. I will give more insights about the RISC-V Coprocessor and new features and how you can use them. We'll run a short demo showing how to evaluate power consumption, and we will wrap up with the nRF Connect SDK and Tools, and I will show you how you can get started with Dev Academy courses. First, the overview. Each device in the series features the same processor, multi-protocol radio, strong security, and a RISC-V coprocessor. They come in different memory sizes, with a broad set of peripherals and interfaces. All share a common architecture that keeps performance and efficiency consistent. That's across all parts in cost-optimized and feature-rich options. With the common architecture, software can be ported freely, and hardware designs can be scaled easily, especially when you have a pin-to-pin compatible option. Currently, there are 4 SoC options in this series. On the left, nRF54L15, L10, and L05, the general-purpose devices. All 3 are in mass production and are already used in end products. SoCs and the development kit are available at distributors. When we announced the series, we promised that the series will be growing. And the new nRF54LM20A is the first step. But there is more to come as well. LM20A expands the series as the high memory option. Currently, it's available through our project-based early access program, where you can describe your project and apply for development kit and device samples. We will review all applications, and once approved, we ship the samples to you. All documentation, datasheets, and SDK support are already available, so you can start development right away. Supported wireless protocols and ecosystems. The series supports Bluetooth LE with additional features and protocols such as Bluetooth Mesh. Also, Thread, ZigBee, and proprietary protocols. On the application level, we provide support for Matter, Aliro, Amazon Sidewalk, KNX. There is also support for location tag ecosystems such as Apple Find My or Google Find Hub. Our software also makes it easy to achieve compatibility with the leading smart home ecosystems. Hardware is just part of the story, so we provide a complete solution for fast development of high-quality products. First, the devices and stacks. A broad range of wireless SoCs with qualified hardware and pre-certified protocol stacks. You can choose the device that fits your product and qualify your product promptly. Second, nRF Connect SDK and Tools. Our SDK gives you a comprehensive codebase with many samples and libraries. This is complemented with hardware and software tools that make development easier and faster. You can pick the modules you need, build on proven examples, and focus on what makes your product unique. Third, mobile apps, cloud, and Memfold. Nordic provides mobile app libraries, samples, and tools. You can reuse or adapt to develop your own mobile application, which is often needed to provide the complete functionality of the product. We've also added OTA updates and device observability through nRF Cloud and Memfold, so you can debug and monitor devices remotely in the field. Fourth, Support and community. For education, start with the Developer Academy. It offers extensive practical courses on Bluetooth LE and the SDK. There is also more. I will cover that later towards the end. For support, visit DevZone, which is the community and support platform. There you can post questions in the forum or create private tickets to get support from Nordic engineers. On DevZone blog and Nordic webinars platform, you will also find more videos and articles on topics not covered here. The partner program is in place if you plan to outsource development. All of this together enables fast, reliable, high-quality product development. Now, let's take a closer look at the SoCs in the series and what features they offer. Let's start with the three general-purpose SoCs. These are the most versatile options designed to cover a wide range of products with different package and memory options. Starting from the left, CSP version of nRF54L15 is already in production, only 2.4 by 2.2 mm with 32 GPIOs. QFN packages are available for all these devices. The QFN48 is also in production, while QFN52 and QFN40 variants are currently available in sampling. Moving to memory, nRF54L15 includes 1.5 MB of non-volatile memory and 256 KB of RAM. The following devices provide smaller memory options. The memory is the only difference. Everything else, including performance and efficiency, is the same across the series. All three feature a comprehensive peripheral set, one high-speed serial interface, which can act as SPI or UART, and four fully featured serial interfaces. A 14-bit ADC, I2S and PDM, NFC, this is A-tag functionality, so you can connect the antenna and get an NFC tag within your product that can be used for Bluetooth pairing, commissioning, Matter devices, many use cases. PWM with new autonomous waveform generation feature. QDEC, global RTC that now can operate in system off for much lower sleep currents. They also integrate advanced security with ARM Trust Zone and RISC-V Coprocessor, which will be covered in more details in the following part. Together, these devices form the most flexible and scalable base in the series. Ideal when you need proven performance with different memory and package options. And by the way, within this group, QFN packages are pin-to-pin compatible. Now to the newly launched LM20A, the latest addition to the series and most capable device. It expands the feature set we've seen, bringing more performance, memory, GPIOs and interfaces. Starting from the left, it comes in compact CSP package, which is already available in the early access program. QFN52 version is planned and will follow soon. We'll notify you when sampling begins. In terms of memory, the LM20A offers 2 MB of NVM and 512 KB of RAM, giving plenty of headroom for advanced applications. It also expands the peripheral set, adding a high-speed USB interface, 2 more serial interfaces, I2S has been upgraded to TDM, and we have up to 66 GPIOs. In short, it builds on the L15 but adds more capabilities. This is an ideal choice for projects that demand more memory, interfaces, or USB. Well, it's a major step forward, and we are quite excited to share that the series has now been expanded with this SoC. In addition to the SoCs themselves, many of our partners offer ready-to-use modules based on the nRF54L series. These modules make hardware design faster and simpler. They're often Bluetooth pre-qualified, regulatory pre-certified, and come with integrated antennas and necessary passives and matching networks. Of course, every project is different, but we often hear from customers that modules make perfect sense not only for very low volume projects, but even for designs that are produced in tens of thousands or even hundreds of thousands of units. So it really depends on your priorities, development time, certification effort, and any other individual reasons. But with the module, there are simply fewer moving parts in hardware designs. But anyway, when you're ready, you can always migrate to your own custom board. Applications. As we expanded the 54L series, we are also expanding the range of applications it can serve. Starting from the left, advanced Bluetooth LE. The 54LM20A and LP15 are perfect fit for complex, feature-rich products such as smartwatches, game controllers, toys, smart ring, healthcare equipment, and so on. Basically anything that needs memory or the ability to use more sensors, actuators, human interfaces, advanced wireless features, more application logic, or run a simple machine learning or Edge AI as it's called recently. All this is available in ultra small packages and can address requirements of size constrained devices. Next, simple Bluetooth LE. The L10 and L05 are perfect for sensors, asset tracking tags, or wearable biosensors, where cost, power efficiency, and compact design are important. Smart home and industrial. Here the nRF54LM20 and L15 really shine. We are extremely strong in this area, especially for battery-powered and multi-protocol devices like sensors or smart locks. Our products support Matter, Aliro, and they have multi-protocol support for Thread, Bluetooth LE, NFC, and Zigbee. They can also work with Wi-Fi through the nRF70 series companion ICs, enabling full smart home ecosystems. Finally, USB-enabled devices. LM28 is a great choice. It supports USB. It can be used for dongles, HID controllers, gaming and other peripherals that need low latency link from a wireless connection to PC, or just need a USB for data transfer for hubs or other types of dongles. Together, these options show how the nRF54L series scales, from simple tags to high-end connected products. So here, I think that it's worth to learn the series, get onto it, and you can see for how many projects in the future these devices can be used. The nRF54L series is the next step forward, and to see how much it's improved, let's compare it to the nRF52 series, its predecessor and the most market-proven Bluetooth LE SoC in the world. nRF52 series earned its reputation through the high level of integration of features in a single IC, reliability, low power, and ease of use. And over its lifetime, it captured a huge share of Bluetooth LE qualified designs. In this chart, you see the distribution of vendors across all qualified Bluetooth LE products that reached qualification. This is a snapshot from sometime last year, but Nordic consistently holds around 30 to 40% every quarter. The vast majority of that used to come from 52 series, and now the 54L series is becoming the leading SoC. The 52 SoCs were shipped in billions of units to thousands of customers. This gave us a great feedback base to build on. Now, with 54L series, we've improved it in many ways. And let's take a look how. The level of integration and scalability, one of the cornerstones. The CPU clock speed has doubled from 64 to 128, and the core has moved from Cortex M4 to M33.
We've added a RISC-V Coprocessor and a couple of new features and peripherals. Apologies for this icon, I couldn't find anything better, so imagine that these dots are new features. We've also expanded both NVM and RAM. The 54LM20A expands the series toward the high-end and high memory. However, we will be expanding more, and the series will grow in both directions, with simpler and more advanced devices. I can't share the details yet, but be on the lookout. Security has also advanced, very important feature these days. The series includes isolated execution environment and root of trust. Security services such as secure boot, secure firmware update, and secure storage are available. It also features protection against physical threats, with protection against side channel attacks and tamper detection. All these security features are ready to meet modern security demands and ready for regulatory requirements. Another major step forward with this series is power efficiency. Nordic has long been a benchmark in this area, and with the generation we are pioneering the move to 22nm process node. This is the first mainstream wireless SoC built in this technology. What's challenging, as you probably know, there are way finer process nodes, but here we are combining analog and digital parts of the chip built in the same process node. So this 22 is really cutting edge these days. The new process, combined with low leakage architecture and advanced power domain control, delivers roughly 30 to 50% lower power consumption. That's for typical Bluetooth LE use cases, and that's compared to 52 series. So that means significantly longer battery life for the product, or the flexibility to add more features and processing while keeping the same battery size. Either way, 54L series gives more freedom to balance performance and power exactly as you need. The series features the latest generation of Nordic radio. It continues to prove that reliable connectivity is the signature of Nordic. We've contributed to Bluetooth LE since its early days, and we are deeply involved in all wireless standards we support. We participate in interoperability testing and make sure that our devices are validated against the latest specs to make sure that this will work seamlessly with devices and phones from other vendors. On the hardware level, we've added Bluetooth channel sounding for accurate distance measurements, and we have also introduced a 4 megabit per second proprietary mode. Previously it was 2 megabits. This enables lower latency and higher throughput compared to standardized protocols. The devices are qualified against Bluetooth 6.0 and will continue to be upgraded as the new features are introduced. Actually, currently we have Bluetooth 6.1, and Bluetooth announced that they will be releasing a new core versions twice a year. So these versions will progress quite fast, and we are moving away from defining the feature set by the version. That's because it's important to realize that since Bluetooth 4.2, new features have been optional, meaning that some vendors can qualify against the latest version without actually adding any new features. At Nordic, we take a different approach. We implement the optional features. So we have channel sounding, PWR, and so on. There is one exception for 54L series. LE audio is not supported here. For LE audio, nRF53 series is the right choice. The radio has also improved selectivity, resulting in lower influence of noise, and has finer output power configuration in steps of 1 dB, so the power consumption and range can be balanced more precisely. To wrap up this slide, this is Nordic's most efficient and capable 2.4 GHz radio to date, and we are continuously improving the stacks to maintain our frontrunner position. So 54L series has been announced some time ago, and it's already proving itself in the field. Developers started back in 2023 with a limited sampling program, and since then adoption has grown rapidly. Compared to 52 series, the pace of adoption is much faster. I can't share too much detail, but I can tell that we've already shipped over 10,000 development kits, which is a lot given the time since the official launch last year. End products are already going through certification and are gradually entering mass production. One of the first products based on 54L series and manufactured in high volumes already reached the market, and this is asset tracking tags from Chipolo. As you can see in the picture, really nice product, long battery life, cool features. Yeah, I can recommend. So as you see, it's a pivotal moment for us because 54L series used to be a project, but these stats show that this series isn't just a new technology. It's a proven platform that developers already trust and use. Now let's move on to RISC-V Coprocessor, the feature that enables quite a lot of new possibilities. This coprocessor implements the RISC-V instruction set and is fully implemented by Nordic. It runs at 128 MHz and is supervised by the main processor. It features unique hardware acceleration for I/O and is optimized for performance. So think of it as an additional processor inside the SoC, something you would normally use as external IC, but for now you don't have to because it's built in. It removes the need for extra MCU or something additional on the PCB. It enables more integrated and simpler design flow. It will always add some power consumption, so for very low power, it's best to fit everything into the main processor. But if you need extra features or more processing capacity, this coprocessor gives you that flexibility. It can implement features in one of three usage modes: coprocessor, soft peripherals, and high performance framework, also called HPF. In coprocessor mode, which is the most flexible, you can run a standalone custom application on this processor. It can enable simultaneous execution of real-time tasks on both processors, on the main one and the coprocessor, or can add extra processing capacity by offloading tasks from the main one. The application is based on Zephyr, so you get access to the same samples, resources and libraries as on the main processor. It supports the same APIs for memory and peripherals, and is all integrated within the same toolchain and IDE, so you get development environment the same for the entire project. Soft peripherals are provided as binaries. They extend hardware capabilities by emulating conventional peripherals, using the hardware acceleration for I/O to achieve high speed. When you use a soft peripheral, you access it through driver level APIs, just like any other peripheral. Currently, QSPI is available at experimental maturity. It can already be used in prototypes. It can run at up to 64 MHz. Quite impressive, given that this is half of the processor's clock speed. The high-performance framework is something in between. It's a low-level framework for developing custom high-speed or timing-critical protocols with more control over timing and execution. It gives direct access to the hardware acceleration of I/O, enables the creation of highly optimized application-specific protocols. That's where performance and timing precision are required. Before wrapping up the part about the features and hardware, I'd like to present the complementary ICs. Nordic provides not only wireless SoCs, we also offer products that enhance the capabilities of our core devices. Starting with the power side, we have the NPM family of power management ICs. They integrate several components that would typically require separate devices, helping to simplify the design and reduce board size. The PMICs provide battery charging, an accurate fuel gauge, and system management features such as watchdog, hardware reset, and power loss warning. The hardware reset can be triggered by a button connected directly to the PMIC, and the early power loss warning activates before the SoC's brownout detector, as it's implemented before the decoupling capacitors. PMICs also include additional GPIOs and LED drivers. These are specifically useful when you design a device powered from 1.8 volts. PMICs are, of course, those that can charge batteries, are USB-C compatible, so your product can be charged with USB-C. For devices that sleep for very long periods of time, there is a hibernation mode with current consumption below 200 nanoamps. I think it's 175 nanoamps. And it also provides wake up in configurable intervals. There is also a ship mode that reduces the current consumption down to 35 nanoamps. That's to extend the shelf life of devices with enclosed non-rechargeable batteries. And also provide great user experience, because then you just push a button and the device turns on. There are no this paper strips in between the battery and so on. On the RF side, Nordic offers front-end modules. These extend range and improve link reliability by increasing transmit power up to 20 dBm. That's the regulatory limit. Together, these companion ICs allow you to control the complete power path from the battery to the antenna, all with Nordic components, and that creates smaller, more efficient and more capable designs that are easy to implement as we take care that our products work together seamlessly. So now we've wrapped up the functionality and specifications part, basically the hardware section. Next we'll shift focus to something just as important, the power consumption. In this part, we'll look at how 54L series achieve long battery life, or how it can enable designs with smaller or lighter batteries, perfect for compact and portable products. Before we dive into details, I'd like you to think about what's most important for your next design. Is it longer battery life, or is it adding more features, or maybe achieving both at the same time? Keep that in mind as we go through this section. We'll explore how the nRF54L series can help you reach each of these goals. And at the end, before the Q&A session, we'll run a quick poll so you can share your perspective with us. That's completely optional, of course. So, achieving longer battery life is the common challenge. Here is what changes with 54L series. In Bluetooth LE cases, I'm presenting the expected and achievable improvement ranging between 50 and 30% for common use cases. That comes from gains in active modes, efficient processing, ultra-low power radio, and also what's happening in idle or sleep, where the important features are independent power domains and the new sleep mode. I will also touch on the DPPI. Let's look at this in detail. First, the main processor and what drives this improvement. You already know that this is an ARM Cortex-M33, but here I will only mention that it is a fully featured core, including FPU, DSP, MPU, trust zone, and additional debug capabilities. You will find all that in the datasheet. To understand performance and efficiency, we use the CoreMark benchmark. It's a standardized test that runs the same piece of code on different devices, and the result shows how many iterations the processor can complete in 1 second. It benchmarks the complete setup with the processor, memory, the complete MCU. As you can see in the chart, the core in the 54L series delivers more than twice the performance of the one in 52 series. But what's even more important is the efficiency, measured as core mark per milliamp, which is about 3 times better. So not only it executes more operations per second, but also it does it using much more energy. That means more processing headroom for your application logic while still extending battery life. Basically, you always win. So what this improvement actually means in practice? Here we're running the same piece of code on 2 devices, nRF54L15 and nRF52840. The result is that the 54L15 executes the code in about 2.4 times faster, as shown in the previous slide. You can see it on the time axis, and it does it with 3 times less average current that you can see on the current axis. If you put that into simple terms, even if your application on the 54L series becomes twice as demanding, it will still consume less current. If you double the processing effort here, it will still consume around 1.5 less power. So you get more processing power when you need it and still longer battery life. That's a big shift for everyone who already optimized their devices to limits with 52. So like progression to 54L series will give instant improvement. Another active mode, because active modes contribute the most to the average current that defines the battery life. So let's examine the radio. Radio is relatively power hungry in such an SoC. So here we are comparing the system current during transmission and when the device is receiving. And we are also comparing L15 to 52840. We're showing the system current here, so it means that we are measuring the entire device, not only the radio itself, but we have the power consumption of the radio, MCU that serves the protocol, stack, and everything at the same time. So as you can see, the improvement is clear, like for transmission at 0, 4, and 8 dBm output power, the current is significantly lower, and it's close to 50% when receiving. In the tables, you get the exact numbers from the datasheet. So let's move on to low power modes. So there are 3 items I would like to highlight: independent power domains, global RTC, and DPPI. 54L series introduces these independent power domains, meaning that different parts of the SoC, like the radio, peripheral blocks, and the processor block, can be powered on or off separately. So whenever a block isn't needed, it can be completely switched off, reducing the average current. The second feature is the global RTC. This is new and important. RTC wasn't available in system on 52 series, now it is. So that means device can maintain timekeeping while consuming less than microamp of current. And finally, DPPI, or Distributed Programmable Peripheral Interconnect. This allows peripherals to talk to each other directly without waking up the main processor. So for example, when data is gathered on an external event occurs or system can, then the system can decide locally what to do. Only if certain conditions are met, like defined number of samples collected, the DPPI can be configured in a way to wake up the processor then. So it's a simple concept, but quite powerful one. So some simple logic can be implemented outside of the processors. If you want to explore these features in more depth, they are covered step by step in the nRF54L series Express course on Dev Academy. So to sum up, the biggest gains come from improvements in active modes, which are dominant, but these lower power mode, sleep modes, also play a significant role. Let's see how it works in practice. Before you get the hardware, you can use the online power profiler. It's available for Bluetooth Low Energy and now also for Matter and Thread. It lets you estimate current consumption for different configurations and connection parameters. And once you have hardware on your desk, you can use the Power Profiler kit. So I'm in DevZone, online Power Profiler for Bluetooth. Here you can pick the chip you're using and adjust the settings to reflect your design. So you have all the settings you need to briefly evaluate the power consumption. Here we have the default scenario that has been used in the presentation as the example where you can achieve 30% of improvement. You can also choose other modes such as only advertising without connectable, connection as peripheral, as central, and so on. So for L15 in this default scenario, which is fairly common, the device is estimated to consume average current of 45 microamps. When we switch to 52840 that we've compared in the presentation, total average current is 94. So just by upgrading to 54L, we're getting 30% less power consumption. 50% is achievable for higher TX power. Here on 52 series we get 129, and when we switch to 54L15 we get 63. I will now switch to the scenario that I have implemented on the board and already flashed. So I will run the Power Profiler kit, and which I will use in source meter. So I will provide the power to the device directly from the Power Profiler. So as you can see, I have it already wired, Power Profiler kit and the DK. I've removed the jumper, so now the power from PMIC is disconnected, and instead I'm powering 54L15 from Power Profiler kit. I will now enable our output and start the measurement. As you see, nothing is happening, but I have the software from the Dev Academy Express course, and it lets me to set 200 milliseconds advertising with a button press. So yeah, I will just get rid of this camera view. So here you see that we've achieved 25 microamps average power consumption. This tool lets you to zoom in to examine the events exactly. You see that it's not very accurate, but it is very accurate for its price, and it's meant for software development mostly, for finding key issues, key bugs. You can see that the device is entering the idle between advertising events. You can measure the average current in this idle state. It is 2.16 micro, slightly lower than in the specification, but that's due to inaccuracy of this device. However, it's very useful to examine if your software performs as necessary. Does advertising interval change? Are other devices that you have connected to your board consuming too much power or are behaving up to specs, and so on? Very useful tool. Let's move on to the nRF Connect SDK. This is the software foundation for all new Nordic SoCs, including 54L series, but it's also broadly used for the 52 series. It provides everything you need: protocol stacks, libraries, samples, and complete applications, all in one place. You'll find drivers for Nordic hardware, plus middleware and external IC drivers from the Zephyr project. That covers everything from simple Bluetooth applications that are very simple to make, up to complex multi-protocol products. Sorry. Today, even basic devices need more advanced features like DFU or security. All that is included in the SDK. But with RTOS support, such features are easier to add, and it's easier to keep your code clean and maintainable. You can select the functionalities you need and build application on top. Start small with a simple sample-based project and scale up to production-grade software. The SDK is Zephyr-based, making it modular and scalable. Zephyr is the fastest growing open-source RTOS, and Nordic has been one of its main contributors for many years now. There is also a bare metal option for developers who can't use Zephyr. It can be used as is, as bare metal thing, or can be integrated with other operating systems. The bare metal option currently supports Bluetooth only. We still recommend investing time to learn Zephyr. It's just more flexible and future-proof. But the code, the software is not everything. We also have the nRF Connect for VS Code. This is a comprehensive extension built specifically for Nordic devices and the SDK. It is designed from the ground up to simplify the development. It combines many tools needed and makes them available in one workspace. You get both command line and graphical interfaces for configuration and debugging. In this slide you can see the screenshot of the device tree visual editor. This lets you easily configure the hardware for custom boards. The extension also includes debugging, memory analysis tools, built-in serial terminal, and kconfig support. It also has SDK and toolchain manager, so you can install and manage SDK versions and toolchains directly within VS Code. No need to switch between different tools. Altogether, it gives you a single integrated IDE. There is also nRF Connect for desktop, and this includes a range of tools for hardware and software that can support many stages of development and testing. Among them is the direct test mode, applications for RF testing, power profiler that you just saw. There is also the programmer for flashing, quick start, which I will cover in a moment, and other useful tools like RSSI viewer, serial terminal, Bluetooth Low Energy app, which is a general development and testing tool, board configurator, and a couple of others. Okay, good. So how to get started? First, the development kits. Currently we have two. They include full access to all GPIOs, built-in debugger, current measurement pins that you saw, buttons, LEDs, external flash, and a couple more features. I already mentioned the PMIC that is on board. They work seamlessly with the extension for VS Code. They are fully supported in the SDK and in the development tools. You can run examples straight from the nRF Connect SDK. Test different interfaces, just regular development. nRF54L15DK, the one on the left, can emulate L10 and L05 devices. You may notice that these development kits are simpler than our previous DKs, and that's because they are software configurable. For that, there is the board configurator that I mentioned, and that's an application where you can adjust several key features of the DK without modifying hardware. With this app, you can connect or disconnect virtual COM ports, disable LEDs when you want to measure power, and it also lets you set VDD voltage supplied from PMIC. It can disable the onboard debugger. Everything that used to be done with jumpers, now it's controlled here, so it's easier, cleaner to switch between projects and so on. So there are a few ways that you can get started. I will mention two. The first one is the Dev Academy. It's the most time-consuming, but also the most in-depth and valuable way to learn about the series. I really recommend this one, especially now that there is a dedicated course that doesn't require any hardware. Next is Quick Start application. It will help you to verify that the DK works correctly. You will flash basic samples and you will progress to development. Quick Start is an option recommended for more experienced users who have worked with Nordic, nRF Connect SDK, and just want to start quickly. If there is one thing I really want to highlight, it's the Developer Academy. It offers structured, hands-on courses with interactive lessons and certificates. Developers rate them 10 out of 10 very often. That's for clarity and practical approach. That's a great starting point. And there is nRF54L series Express course focused on hardware. A lot of topics from this webinar are presented with way more depth. It gives a step-by-step introduction to the new architecture, features, performance, power domains, DPPI, and it even includes a lesson on power efficiency that you can use with the DK, as the previous parts of this course don't require a DK to complete. If you're more interested in software, get a DK for Nordic product and go directly for the nRF Connect SDK fundamentals or Bluetooth LE fundamentals. They will give you a deeper dive into Zephyr and into the SDK. The courses are free, take a couple of hours to complete, so they are fairly intense, and honestly this is the fastest way to build confidence, master the tools, and grow your skills. I hope you'll remember this address, academy.nordicsemi.com. And with that, we're at the end. So let's take a moment to wrap up. You've seen the tools, the SDK, the architecture. Now it's your turn to explore it, build with it, and see what you can create. A final note for people who are watching this on YouTube: if you enjoyed this webinar, please leave a like and comment. Okay, hey Sam,
hello.
Thanks for joining. So the first question is from Marcus. Let me display it. Given the 4 megabits per second proprietary PHY, is there any hope for HDT in the future? So HDT is being specified now. It has been disclosed by Bluetooth SIG, but it requires support on hardware level. So currently released 54L series devices cannot support these features, but we are involved in the HDT development. Next question to you, Sam, about audio PLL.
Yeah, so this is regarding the peripheral clock 24 megahertz. So this is a standard 24 megahertz peripheral clock. So it's not an audio PLL. The nRF54L has an audio PLL which can be tuned to precise frequencies to account for clock drift, and this is something you need for some LE audio applications. This feature is not available in the nRF54LM20, so if you need this, you should look towards the 5340.
What applications are enabled by 54LM20. So it's a perfect fit for more memory intense applications. How more intense? That's for you to discover. For sure, it gives much more headroom when you want to use Matter, for example, and more advanced protocol stacks. There is plenty for the applications. About cameras, to be honest, I'm not sure. You need to try to evaluate, but cameras may be quite intense. However, we've had the demo with camera. Do you remember some? What camera was it? And resolution be provided there?
Yeah, so I don't have those numbers straight off, but definitely I think a basic camera functionality could be supported on the 54LM20. I think one of the other applications we should highlight here is Wi-Fi. So we are coming with Wi-Fi support for the 54LM20, working together with the nRF5000 series of companion SoCs. So if you're interested in Wi-Fi, I highly recommend taking a look at that as well.
Good. Next one also for you. And there was a follow-up question to this one, so maybe you can answer all.
Yeah, so in terms of memory left for the application after the stacks, I think the follow-up here was talking about also adding thread and Wi-Fi support. This depends a lot on also your configuration and the exact features that you need. So the best thing really with these kind of questions is to create a ticket on DevZone with your specific use case to discuss your needs, or just to try it for yourself. So you can easily build an application combining these stacks with the nRF Connect SDK to evaluate what the memory footprint of these is. And DevZone are always also happy to help you with things like optimizing the memory footprint. So if you've already built an application and you want to make sure that you are building it in an optimal way and excluding the features you don't need, you can also reach out on DevZone for support with that.
And a simple question, how many PWMs? It's 3 PWMs with 4 channels each. So it's 12 channels in total. Next question that I won't display as it has some like classified data, but to the person who asked this question, please let us know which distributor is showing QFN variant for LM20 as available. This is very likely a glitch. So currently LM20A is only available through early sampling program, and we also haven't started sampling QFN package yet. Please contact us for the information about the timelines there. Okay. A question about Bluetooth mesh.
Yeah, so I can take this one. So there's no reason why Bluetooth mesh can't be supported on the 54LM20A. So we support it on the 54L15 today. The support is not available in the SDK currently, but if you need that support, please, what I suggest is reaching out to your Nordic sales contact, and we can use that discussion to decide the priority on adding this support. But there's no reason why this can't be added if it's needed.
A question about reference design for channel sounding or DK. So channel sounding is in our focus. We are not disclosing upcoming development kits. So currently there is no development kit for multi-antenna channel sounding, but you can drop us a message or contact through the contact form, and we can share more information about channel sounding there. One more question about LE Audio.
Yep, so I can take this from.
Thanks.
Yeah, so this is following on from the question earlier on. So the 54LM20A doesn't include an audio PLL, and you need this for some LE audio applications where the receiving device needs to synchronize to a transmitter. This is particularly needed when you're doing things like a true wireless earbuds or other applications similar to that. We don't have an audio PLL in the 54LM20A, so that's why it's not recommended. But some LE audio use cases can be fulfilled, but it's a subset.
One more for you, Sam.
Yeah. So the Apple Find My application source code, if you get access to this, this runs on the ARM Cortex M33, not the RISC-V. And this fits with our intended use case for the RISC-V coprocessor, which we talked about in the webinar. Yeah, this is not the intended use, but the Find My application can run alongside your own application on the ARM Cortex M33, and we have customers doing that on the 54L series already.
Okay, next question is about FEMs and usage of front-end modules with channel sounding. So I got a very brief answer from my colleague that you cannot use FEMs with channel sounding, but for multi-antenna designs, third-party switches are necessary. Okay, we are after time, but I think we can take a couple more questions. Sam, you can pick maybe 2 questions that you would like to answer, and then we'll have to wrap up.
Yeah, we have a question on will we ever provide a version of the 54L15 with double the available RAM? Well, I guess that's the 54LM20A. You get double the amount of RAM and with some extra non-volatile memory. We don't comment further on roadmap in public webinars, but if you have some specific needs, we'd always encourage you to talk to Nordic sales. And then there's a question about the nRF7002 eval kit, compatible with the nRF54LM20A dev kit. Yeah, this is definitely planned to be able to support Wi-Fi easily on the 54LM20A dev kits.
In the answers, I will often mention reaching out to our sales. So if you don't have direct contact with sales of a distributor representing Nordic or directly at Nordic, you can always go to product page and there is a red button saying ask us about, and there you can put your questions somebody should answer. The alternative way is to ask on DevZone. The same answer is for the question about the kits. Okay, and the next one is about channel sounding and its precision. So channel sounding is designed for applications like locks, access control, personal item tags. So the precision or accuracy that we see in our demos is around 0.5 meter for a single antenna. It can be finer if you use 2 antennas, but it depends on the design. These applications should give a grasp of what the precision or accuracy is. Let me take a look at my notes. Okay, Sam, can you answer this question about mesh, please?
Yeah, so Bluetooth mesh, we support this already today for the other devices in the 54L series. So you'll find the support in nRF Connect SDK for Bluetooth mesh on the L15, nRF54L10, and nRF54L05. It is planned for the 54LM20A for release later. If you're waiting for this, please speak to Nordic Sales and let them know you're waiting for this so that we can make sure it's prioritized for you.
Do we have a kit that lets you to connect Ethernet? We normally don't provide the information about plans, but I think I can share that we are not planning to launch such a module. So you need to find something to attach additionally to our devices. Sam, a quick question about LE Audio.
Yep, so LE Audio on the 54L series. There are a subset of LE Audio use cases that could be supported on the 54L series, but the 54L series cannot support all LE Audio applications. Our recommended device today for LE Audio is the nRF5340, which includes an audio PLL, which is one of the peripherals that you need to support some LE Audio applications. But if you have a specific question on a specific application, again, yeah, reach out either to Nordic Sales or on DevZone, and we can provide some better guidance depending on your specific use case.
Good. Using BLE, channel sounding, and NFC all together, yes, that's possible. Channel sounding is designed in a way to be used in parallel with regular Bluetooth LE, and NFC can be used as well. This one for you, Sam.
Yeah, so the RISC-V core. So the RISC-V core essentially is a Nordic implementation of a RISC-V core. So RISC-V is just an instruction set. So the flipper or FLPR core that's in the nRF54L series is a Nordic design core, and this contains our use and implementation of the instruction set, as well as peripherals, special peripherals which enable the implementation of these very low-level soft peripheral functionalities, which gives a very highly deterministic performance and interface with the GPIOs to implement things like the soft Quad SPI that we've released.
And one more about RISC-V.
Yeah, so the RISC-V and ARM core are sharing the same NVM and RAM. It's recommended for the RISC-V to run small optimized applications directly from RAM. This is how you can ensure that they're not impacted by this shared memory. If the RISC-V is running from our RAM, then there will be wait states if both the ARM Cortex and RISC-V are trying to access the NVM concurrently. And the same applies if executing from RAM. However, when you have concurrent accesses there, the wait will only be a few cycles. And you also have the option in the nRF54L series to make sure that the RISC-V code is in one of the two RAM banks. So you have two RAM banks in the 54L series. So you can use one of them for the RISC-V and one of the ARM Cortex if you really need to be sure that there's no wait states on the RAM access.
How can we achieve 20% less current if we have the same signal output? So the gains are achieved. So there is, of course, we're not bending physics laws. You need to put in power into antenna to emit the signal at a certain certain power, but there is an overhead to generate the signal in the radio, to modulate it, to handle stack of given protocol, and the gains are achieved there. Is coded PHY supported? Yes, it is supported. How much different from the 54H the series is? 54H has two processors. That's the two ARM processors running up to 320 megahertz. That's the key difference. 54H also has more peripherals. However, 54H is currently available only in sampling to narrow group of selected customers as we are ramping up with this product now. 54L is broadly available. Will we support JetBrains C-Lion in the future? I don't know, to be honest. Yes, you can develop on PC, Mac, and Linux. We support all platforms. Currently, we don't have a dedicated Dev Academy course on NFC. It's fairly simple peripheral, quite easy to use. It may be supported in one of the lessons, but I'm not sure about it. You would have to check. Okay. We are out of time, so we'll have to wrap up. We managed to answer almost all questions. There were also a few questions in the chat, but we won't be going back to these. For future webinars, please remember to put the questions in the questions tab. Thank you very much. Sam, thank you for joining, and see you all in the next Nordic Tech webinars.